All right, so 8.2. That's the one where we're talking about compound inequalities. That's with the words and or are. Remember, with the word and, you're looking for the intersection. And the word are, you're looking for union. So and is intersection, are is union. So and is where the two graphs overlap. So that's, remember, on A2, those of you that turned it in already, and the rest of you, you're supposed to draw the two graphs. And then the answer goes on the graph that's on the worksheet. And it's wherever they overlap. The union, the R, is anything that's shaded. Anything that's shaded. All right, so on your next test, if you had this problem, let's say you want to solve negative x plus 4 is greater than 6, and 1 plus 3x is less than or equal to negative 11. All right, so you're supposed to recognize that's a compound inequality. If it was just one of them, that would have been in your test 2. That would be in a simple inequality. But the fact there are two of them with the word and or the word are makes it compound. So it's a compound inequality. So remember, you got to solve each one individually. So how do you find the solutions to this inequality? So you get the variable by itself, so you can subtract 4 from both sides. Combine like terms, so I get negative x is greater than 2. Now how do you get x by itself?
Divide both sides by negative x.
Not negative x, divided by the variable, negative 1. No, not negative 1x either, it's negative 1. All right, because remember, in the previous worksheets, some of you lost points because you divided by the variable. You cannot divide by the variable. You guys say divide by negative 1. Now, since I'm dividing by negative 1, remember, you got to reverse the inequality symbol. That was on test 2. So negative 1 divided by negative 1 is 1. 1 times x is x. But my solutions are any real number that is what? Less than what? Negative 2. All right, so that's the solutions to this inequality. Now let's find the solutions to this inequality. So how do you solve this inequality?
Subtract 1 from both sides.
All right, so combine like terms, I get 3x is less than or equal to negative 12. Next step, both sides by 3. 3 divided by 3 is 1. 1 times x is x, so x is less than or equal to negative 4. All right, so any real number less than or equal to negative 4 is the solution to this inequality. But I want to find the solutions to the compound inequality. So what's the next thing you need to show? The graphs of each of those solution sets. So this one is x is less than negative 2. So let's say this is negative 2. Open a closed circle. Going which way? To the left. All right, now I'm going to graph the next one. X is less than or equal to negative 4. Now where do I put negative 4 in terms of this number line here? To the left or the right of negative 2? To the left. So negative 4. Open a closed circle. Close, going which way? To the left. All right. And now remember, you got to show this. Now, on your worksheet or the test, I'll give you the number line. That's where you put the, and it'll be marked. Okay, so it'll be marked. So that's where the solutions to the compound inequality go. So given the graphs of each inequality, how do you determine what the solution to the compound inequality is? Where they intersect, where they overlap. So they overlap here, right? They stop where? Negative 4. So my solution would be start with -4 and going which way? To the left. Open or closed circle? Closed to the left. So that's the solution set. So that's the graph that you would give me. What was the interval notation?
It would be
Negative, parentheses, negative infinity, -4.
With bracket. Okay?
drawing the number lines when I'm doing them separately. Trips me up because, I don't know, I put like 0, 1, like I put so many numbers.
That's fine. I would just put the numbers that are important here.
Well, that makes it easier because what I was doing
Yeah.
wasn't working at all.
All right. Okay, so let's look at number 44. Number 44. And this is on page 1230. All right, so we have this. All right, so that's what we have,
Is that a -5 there?
a -5.
Distribute.
Okay, so you're going to solve each one individually. It's a compound inequality. You need to know that. It's compound inequality because there are two inequalities with the word "or" between them. So you have to remember, well, to solve a compound inequality, I've got to solve each one individually. I got to find the solutions to each of them, and then I look at those individual solutions and find out what the solution is to the compound one. Knowing this is an OR statement, and OR is anything that's shaded. It's the union of all those solutions. So to solve the first one, if that was on your test 2, how would you solve that one?
Distribute first.
Distribute. So I get 5x minus 5 is less than or equal to a -5. Next step,
Add 5 to both sides.
combine like terms. I get 5x is less than or equal to 0. Next step, divide both sides by what? 5. 5 divided by 5 is 1. 1 times x is x. So in this case, the solution to this first inequality is any real number that's less than or equal to 0. Okay, now the next one. What are you going to do there? Subtract 5 from both sides. 5 subtract 5 is 0. What's on the left? -1x or -x, right? It's less than or equal to 6. What's the next step? All right, so I got to divide both sides by -1 to get x by itself. Now, since I'm dividing by a negative number, I've got to reverse the inequality symbol. -1 divided by -1 is 1. 1 times x is x. So the solutions to that second inequality is any real number that is that's not due today.
-6.
But you can turn them in if you want to.
-6.
Okay. All right. So then you graph each one individually. So remember, you need to look at 0 and -6. So if I say this is 0, then -6 would be on which side of this number line? The left side of 0. All right, so let's talk about the solution set to that first inequality. So at 0, is it open or closed? Going which way? To the left. So I want this one, the solutions for the second equality is any real number greater than or equal to -6. Open or closed? Going which way? To the right. Okay. All right. Now, remember, this is an OR statement. So OR means union, anything that's shaded. So I'm going to draw, just like in the previous one, anything that's shaded. So you tell me where to stop. Stop here? It keeps on going, right? So what do you notice that I've shaded? every real number is shaded. So in terms of the number line that appears, if I have, and it'll be numbered, you would just shade in the whole thing, just like this, with the arrows. Okay, so any real number is a solution. Now, what does that look like in terms of an interval notation? Parentheses, negative infinity, comma, positive infinity, parentheses. Okay. All right. All right, so that was 44. All right, let's look at number 56.
I'm sorry, Keith, can we go back to that one?
What about it?
So when it's, okay, so it includes zeros, but. Okay, no, it makes sense.
You got it? Okay. Everything is shaded. Yes.
So, it's not from 6 to 0, right? It's just like everything.
No, it's not 6 to 0, negative 6 to 0, because it will be negative 6 to 0. That's an and statement. That's not an and statement. An and statement is the intersection. So if that was an and statement, then the solutions would be from negative 6 to 0. But it's not an and statement. It's an or statement. Or statement meaning anything that's shaded is a solution. So for example, if I pick this number right here that I'm looking at, see this number right here? Let's say that's negative 8. Is negative 8 a solution to this compound inequality? All right, well, let's check it here. All right, let's check it here. 5 subtract a negative 8. Subtract negative 8 means a positive 8, right? 5 plus 8 is what? 13. Is 13 less than or equal to 11? No. But it's still a solution because this is an or statement. Or statement meaning that whatever number I choose has to satisfy at least one of these. It doesn't satisfy this one. That's no big deal. It satisfies what? That one. What's negative 8 subtract 1? Negative 9. Negative 9 times 5 is a?
Negative 9 times 5 is negative 45.
Is negative 45 less than or equal to negative 5? I said negative 9. Yeah, negative 9. Negative 9 times 5 is 45. Negative 45 is negative 45 less than or equal to negative 5?
Yes.
Yes. So it's negative 8 a solution? Yes. So that's why it's shaded. That's why it's shaded here. Okay, so you have to know the difference between an and statement and an or statement. Okay, so and means anything that's shaded is a solution because it satisfies either one of those. An or statement. An and statement means that it's got to satisfy both. So if that was an and statement, would negative 8 be a solution? No, because it didn't satisfy that one. Okay? So it's where they overlap that would be a solution if that was an and statement. All right, so you got to know the difference between an and an or. Or is anything that's shaded, and is where they overlap. So that's why it's important you shade them like these. All right, so that's 44. Let's look at 56. 56. All right, 56. All right, 56. You have 3/8x plus 1 is less than or equal to 0, or negative 2x is less than negative 4. All right. So you have this compound inequality. Now, obviously, that second inequality, the one on the right, is the easiest to solve. So let's do that one first. How do I solve this inequality? How do I find the solutions to this inequality? Divide by negative 2. And I got to reverse the inequality symbol. Negative 2 divided by negative 2 is? 1. 1 times x is? So the solution to this inequality is any real number that is what? Greater than?
Negative 2.
Positive 2. Okay, so I found the solutions to that inequality. Now let's find a solution to this one. So here I'm going to subtract 1 from both sides. And so I get 3/8x is less than or equal to 1, correct? Now there are multiple paths you can take now. I'm sorry, -1, yeah, thank you. So the multiple paths that you can take now, you can find the LCD and multiply both sides by, and then divide by 3, or you can right away, since you know the coefficient's 3/8, how do you get x by itself? Divide by what? By 3/8, right? So you understand that you could multiply by 8, right? That's the 2 problems you have to do in your test. So let's go ahead and do it that way. So you'd say times 8 times 8, correct? So 8 and 8's 1, 8 and 8's 1. What's left over here though? 3x is less than or equal to -8, and then divide by what? 3. So the solutions to this inequality would be any real number that is what? Less than or equal to a -8/3. Okay. All right. Now, so I found the solutions to each one. This is an or statement. Keep that in mind. Now we're going to graph each one individually. That's what you have to show. You have to show each one individually. Okay, so let's do the first one. X is less than or equal to -8/3. Now you got to remember about -8/3. So let's think about -8/3. Since that's an improper fraction, it would help you to determine where to draw on the number line if you put this as a mixed number. So -8/3, remember that's 3 into 8 is 2. 2 times 3 is 6. Subtract, you get 2. So -8/3 is a negative what? 2 2/3. All right. So here's 0. So -8/3 will be on this side, right? Where do I put a -8/3? Closed circle, going which way? To the left. Okay, now let's do the next one. X is greater than 2. Where do I put 2? The right or the left? The right. Now you didn't have to put the 0 there. I'm just using it as a mark. Open or closed? Going which way? To the right. Okay. Now remember, this is an or statement. So I've graphed the solutions to each inequality. Now I want to find the solutions to the compound inequality. So since that's an or statement, I'm going to shade in anything that is a solution. So that's the solution right here, right? Going towards -infinity. So tell me where to stop at this point. Stop there, and then I keep going, and then tell me where to start again. At 2. All right. So when I graph the solution to the compound inequality, it's kind of like there will be 2 intervals. 2 intervals. It's like 2 rays. All right, so when I graph this, now remember this is where it's going to be labeled. So 0, -1, -2, -3, -4, 1, 2, 3, 4. Okay. So now before I go on, if this was an and statement, what would the solution be? No solution. Very good, because they don't overlap. All right. So I'm going to put a closed circle at -8/3. So you got to determine where -8/3 is here. So -8/3 we know is -2 2/3. So it's between what 2 integers? -2 and -3. Closer to which one? -3. So let's put the closed circle here. And remember, this is -8/3. Going which way?
-2 2/3, would you count that wrong?
No, you can put -2 2/3. Yeah, doesn't matter. So I shade in which way? To the left. All right, now, what else do I need to shade in? Open or closed? Going which way? To the right. So there's your graph. Now the interval notation. You go from left to right. So I'm going from where? Negative infinity to negative 8/3 or negative 2 2/3 with a bracket. Now remember, the R means union, right? So I'm unioning two intervals. So mathematically, you really should say union, and then what other interval? Parentheses 2, comma, infinity. Okay? Now, if you did not put the union, I'm not going to take off any points, but it really should be there.
We tested, so it'll be there, right?
It really should be there. If you just leave it off, I'm fine with that. All right. Okay.
What is this again? 8.24
8.2.
or A, B, C, just 8.2?
It's actually all of them.
Okay, cool.
Okay. Okay. Let's look at number 64. 64. Number 64. All right, you have negative x is less than 7 or 3x plus 1 is less than negative 20. So negative x is less than 7. All right. So you have to recognize, well, is this a simple inequality or is this a compound inequality?
Okay.
Compound inequality. So you have to find the solutions of each one individually, then determine which solutions are based on the word and or are. So remember, and means it's got the solution has satisfied both. R means either one. So yes, to solve the first one, you are going to divide both sides by negative 1. Since I am dividing by a negative number, I've got to reverse the equality symbol. So negative 1 divided by negative 1 is 1. So I get x. So my solution is going to be any real number that is greater than negative 7. Okay? All right, now the next one.
Subtract 1 from both sides.
Okay, combine like terms. I get 3x is less than negative 21. Next step,
Divide both sides.
divide both sides by 3 and then reduce. So that's going to be 1x, or x is less than a negative 7. All right. Now, let's draw each one individually. So x is greater than negative 7. If this is 0, negative 7 is here. Open or closed? Open. Going to the right, correct? Okay. Now, next one, x is less than negative 7. Negative 7 right under the other one, correct? Open or closed? Going which way? To the left. Okay. Now, this is an or statement. So or means anything that's shaded. So everything that's shaded, all of it except what? Negative 7. Negative 7 is not shaded. It's an open circle in both of those. So we got to keep that in mind. So we got to notice that negative 7 is not a solution. All right, so we know that negative 7 is not a solution, but everything else is, right? So it's any real number except, in our mind, it's any real number except what? Negative 7. All right, so let's see what the graph looks like. So if this is 0, 1, -1, -2, -3, -4, -5, -6, -7, -8, -9, and so on. So it's everything but -7, correct? So at -7, what will I draw? Open or close circle? Open. And all you do is shade everything else. Everything else is shaded. That's what that looks like. So everything is a solution except what? Negative 7. As an interval, what's the answer? To what? Good. With a parentheses union, and then what? Negative 7 again to what? Infinity. So what that means is that everything is a solution except negative 7. Uh-huh. Okay. All right, now let's look at this idea. Okay, so remember when we first started talking about this compound inequality? 3 is less than x is less than, let's say, 8. Okay? That was on the first worksheet in 9.7, I think. And in fact, that was on your test, and you're asked to graph this. So the solution would be any real number that's located where? Between what?
8, 3, and 7.
Between 3 and 8, right? Between 3 and 8. So the graph, that's what you do on the test, right? Okay? Now, remember what that meant. That means that when we first started talking about this, that meant that my solution would be any number that's less than 8, right? And at the same time, it has to be what? Greater than 3. So the solution is any real number less than 8, and at the same time, it has to be bigger than what? Okay? So the solution is any real number less than 8, and at the same time, it has to be bigger than 3. That's what that meant. Now notice in that sentence I used the word and. And. So when I write this as an inequality, look at how it looks. So the solution is any real number, to call that x, that's less than 8, so it looks like this, right? Any real number that's what? Less than 8, and x has to be what? Greater than 3. So when the compound statements on that test 2 that you have to graph, those are actually compound statement, what word? And. Those were and statements. Those are and statements. So these compound statements look like this, where x is between two numbers, is a compound statement with the word and. Now, let's look at this. So this is number 26. Looks like this. Negative 2 is less than or equal to x plus 3 is less than or equal to 0. Now that's a compound statement. When we first started talking about this in 9.7, we stated that was a compound statement. We didn't say it was a simple inequality. It's a compound inequality. We know why now it's called a compound inequality, because it can be rewritten with what word? And. All right. But don't rewrite it with the word and. Don't separate it. It is a lot easier to solve this kind of compound inequality if I can get x in the middle. So I want you to think about this. If I cover this part up here, how do you get x by itself? Subtract 3, right? You would say subtract 3, subtract 3. But it's not a simple inequality. It's a what? Compound inequality. And think of this as 3 parts: the left, middle, and right. So if I get x in the middle, I've got to subtract 3 from all parts. So I subtract 3 from here. And then combine like terms. Because it kind of makes sense, because if I cover this part up, isn't that what you would do? Okay? So what's a negative 2 and a negative 3? Is less than equal to what? X is less than equal to what? Negative 3. So I found the solutions to this inequality. My solutions are any number that's what? Between negative 5 and negative 3. So that's how you solve these compound inequalities. It's very easy to do. It's just like solving a simple inequality, except this time you have 3 parts. Okay, so now let's graph this. So here's negative 5. Here's negative 3. A negative 5 and negative 3, they're both open or closed circles? Closed, because they both have equal signs. And I shade in between them. And what's the interval notation? Bracket, negative 5, comma negative 3 with a bracket. Now you got to make sure there's one of you that are not drawing brackets or parentheses. You're doing something like this. I'm not sure what that is. That's not how that's not a bracket. That's not a parentheses. All right. Okay, so that's 26. It's not that difficult. Let's look at 28.
So kind of in that, get x in the middle, and the problem, not x by itself, but you want x in the middle.
Yeah, I mean, if you cover this, cover this right here, you're getting x by itself.
Right.
Cover this, you are getting x by itself. So when you're solving these compound inequalities, you want to find a solution. It is easy just to get x in the middle, and that will be the solutions to the original statement. All right, 28, you have 1 is less than 4 plus 2x is less than 7. Now what kind of statement is this? What kind of inequality is this? Compound. Because I can rewrite it, I can separate it into an and statement. But don't do that, leave it like that. Subtract 4 from all parts. Subtract 4, subtract 4, subtract 4. It kind of makes sense, because if this was covered, that's what you would have done in the last test. If this is covered, that's what you would have done in the last test. Combine like terms. 1 and a negative 4, negative 3 is less than 2x is less than 3. And finally, what's the next step? If I cover this, how would you have solved for x?
Divide everything by 2.
Yeah, so divide all parts by 2. And so your solutions would be any number between negative 3 halves and 3 halves. Okay, so you found the solutions to the original problem. Kind of makes sense, because give me a number that we're saying is a solution. Give me an integer that's in here. First of all, you got to know what 3 halves is, right? 1 and a half. You got to know what negative 3 halves is. Negative 1 1/2. So give me a whole number, or give me an integer between negative 1 1/2 and 1 1/2. 1. Let's see why it works. What's 2 times 1? What's 4 plus 2? Is 6 less than 7? And at the same time, is it bigger than 1? Yes. Give me a number that's not a solution. 2. Good, because 2's over here. What's 2 plus 2? 2 times 2? 4. Still correct, right? 4. 4 plus 4? 8. Is 8 bigger than 1? Yes, but what's the issue? 8 is not less than 7. So that's why 8 is not going to be shaded. 2 is not going to be shaded.
It has to be a solution for both.
It has to be a solution for both, because it's an and statement. So here's 0, here's negative 1, negative 2, 1, 2. Okay, so at negative 3/2, which is right between negative 2 and negative 1, correct? So right here, just negative 3/2, and you could have said negative 1.5, does not matter. Oh, I put in a closed circle. I meant to do what? Open. Open circle. And at 1.5, yeah, you're right. And I shaded everything where? Between them. And then your solutions would be, for your interval notation rather, would be what? Parentheses, comma, parentheses. Okay? And it's all these things are. Now let's look at 30. 30. It's not that difficult. You got to know how to do test 2 in order to do this. You said what? You have to know how to have done the problems on test 2 in order to do this. Okay. Probably the easiest way to do that one is you see you have that fraction, right? And so you would think, well, I'm going to go ahead right away and multiply both sides by the LCD. Let's not do that just yet. Let's not do that. Let's go ahead. If I cover this, it's easier just to do what first? Add 5 to both sides. In this case, I'm going to add 5 to all parts. So plus 5, plus 5, plus 5. And notice what happens next. So when I do that and I combine like terms, negative 2 and 5 is 3. So 3 is less than what, though? 1/2 x. And that's less than 6. All right, so that's where I'm at. Now let's talk about the LCD. What's the LCD? 2. So I'm going to multiply all parts by 2. So I'm going to rewrite this over. And we say times 2, times 2, times 2, right? Just like you did in the last test. So my solutions then would be any real number that's between 6, because half of 2 is what? What's 2 times a half? People, what's 2 times a half? 1. Half of 2 is 1, right? 1 times x is x. And that's less than what? 12. So solutions to the original compound statement would be any real number that's between 6 and 12. So let's see why 5 doesn't work. Well, let's not do 5 because I'm taking half of, well, that's fine. I can say 5. What's half of 5? 2.5, 2.5, right? What's 2.5 subtract 5? Negative 2.5. Is negative 2.5 bigger than a negative 2? No, it's less than. So that's why it's not a solution. That's why 5 is not a solution. But give me a number that is a solution. 7? You want to do an odd one again? Well, half of 7 is 3.5, right? 3.5. 3.5 subtract 5 is negative 1.5.
You're saying 5 minus 3.5, though, not negative.
Say again?
You're saying 5 minus, not negative 5.
Well, but what, Angela, what is 2 minus 3? What is 2 subtract 3?
You're saying 5 minus.
Well, subtract minus, same thing.
5, 3.5.
3.5 subtract 5. 3.5 minus 5.
Is 1.5.
Negative 1.5.
How? 3.5 plus 1.
3.5 subtract 5, or 3.5 minus 5. The subtract minus mean the same thing, Angela. So when you
Negative 5, 3.5 from negative 5, or
no, I'm saying negative 5 from 3.5.
okay, but you were saying 5 just now, so that's why.
That's what this is. I'm reading it as 3.5 subtract 5. Someone else could have read it as 3.5 minus 5. Someone else could have said this, 3.5 plus a negative 5.
Right, but you said 5 minus 3.
I did not say 5 minus 3.5. I said 3.5 minus 5.
Okay.
All right? So, and I know you look at those videos because you work very hard.
I can't see anything up there.
So if I said 5 minus 3.5, I want you to let me know. Okay? I said 3.5 subtract 5. 3.5 minus 5. So 3.5 minus 5 is what? Negative 1.5. Okay. Is negative 1.5 less than 1? Yes. Is negative 1.5 bigger than negative 2? Yes, that's why it's a solution. Okay? Let's see why 13, let's do 14. Let's see why 14 doesn't work. What's half of 14? 7, that's quick. 7 minus 5, Angela, 7 subtract 5?
7 minus 5 is
2, good. Is 2 bigger than negative 2?
2. Yes.
Yes, but the issue is 2 is not what?
Smaller than.
Smaller, less than
Right.
1. Okay, so make sure you understand what it is you're finding in relation to the original problem. Okay, so that's what all that means. All right, so I found the solution to the original, so it's any number between 6 and 12. So I graph it. Here's 6, here's 12. Open or close circle on both.
Open.
Good. Which way? Where do I shade? Between. All right. And so inner rotation would be parentheses 6, comma 12 parentheses, and that's it. That's all it is. Let's look at 32. All right. So you're going to see one like 32. So let's talk about how to deal with that. The easiest way to deal with that. So here's 32. Now, that's a 5 here. That's a 5. Now, before I do that one, let's do a simple one first. Let's do an easier one first. We're going to come back to this, and let's do an easier one. I'm going to go to the next page and do an easier one. Suppose I had this. All right, suppose I had this. And you gotta know how to deal with this kind. When we talked about these compound staples in 9.7, they were easy to graph. But what if I had this one? All right, what if I had that? Now be careful. X is not by itself. Negative x is in the middle. Divide all parts by negative 1. Okay? So I'm going to rewrite this over because I'm going to come back and talk about the solution to this. So divide by negative 1, divide by negative 1, divide by negative 1. But remember, I'm dividing by negative numbers, so I've got to reverse both of those. Just like you did on test 2. Negative 3 divided by negative 1 is 3. Is what? Greater than positive x is greater than negative 5. All right, so that's where we're at. Okay, now remember this. If I had 3 is less than x, that means the same thing as what? X is greater than 3. Okay, we talked about that a while back. So if I have this right here, if I have this right here, 3 is greater than x means x is what? Less than. X is greater than negative 5 means negative 5 is what? Less than. So the thing is this. Here's where some of you can get tripped up. You're going to say, all right, I got x in the middle, so I'm going to put these on the number line, and you're going to do this. You're going to say 3, negative 5. That is not correct. That is not correct because on the number line, you got to put it in correct order. What should go first? Negative 5 should go first, and 3 should go second, right? So you got to say this. And then I need for you to understand that this right here means all the numbers that are between -5 and 3. That's what that means. So open circle, shade in between them. Now you might say, well, but how do I know that this is this? Well, because we can rewrite it just like we did this. So I can rewrite it backwards, just like I did this. So I can say -5 is what? Less than x. And I can say x is what? Less than 3. And that's what this is. So you have to make a connection between what you've learned before to this. How you can go from here to this. But a common mistake is that students will draw it like this, shade in, but it's not correct. The same thing this. They'll sometimes do this as well. They'll say, all right, the solution are between 3 and -5, because that's what that says, and they'll do this, 3, -5. That is not correct. Because when you write an interval, you got to go from smallest to largest. That's not what that is. 3 is not smaller than -5. So it's important when it looks like this to rewrite it. So that way you can draw it carefully. So what is the interval notation? -5 to 3 with parentheses. Now we can do number 32. All right. Now, the difference between this one and this one was over here, it was a lot easier to add 5 to all parts first, and then multiply all parts by what? 2. Here is don't subtract 5 from all parts first, because that is not just +5. That's 5 divided by what? 3. So you got to be careful. That is not +5. So don't say you're subtracting 5, because if you were going to do that, that should really be subtract 5/3. So the best thing to do first is to multiply both sides, all parts by 3. That's the quickest way to do that one first. Yes?
It's -2x
-2x.
plus what?
+5. So again, do not say subtract 5, subtract 5, subtract 5, because that is not -2/3 plus 5. It's it's -2/3 x plus 5/3. Okay, so it looks different than this one. Okay? All right, the quickest way to, Yeah. The quickest way to do this one, though, is to use the LCD right away. So I'm going to multiply all parts by 3. And notice what happens when I do that. So all I did was just rewrite this over. Times 3, times 3, times 3. What's -4 times 3? -12 is less than or equal to the 3's divide out, and what is left? -2x plus 5, and it's less than or equal to what? 3. And now you've made it a lot easier for yourself. You clear the fraction. Subtract 5, and then at the end you're going to divide by -2. So remember, they divide by negative, so you're going to go back to the one we just did to help you. So you can subtract 5 from all parts, correct? Combine like terms. What's going to be over here?
-17.
All right. Is less than or equal to -2x. Is less than or equal to,
Do you want us to flip the signs or not yet? Oh, wait, this
not
time.
yet. You haven't divided by a negative
No.
number yet. -2. All right, now I'm going to rewrite this over. What's the next step? Now, since I'm dividing by -2, I'm going to circle those inequality symbols. Remind me I got to reverse them. Okay, now you got to know that a negative divided by negative is a positive. So you got to rewrite this as a positive 17/2 is what? Greater than or equal to x is greater than or equal to 1. Now, on the number line, are you going to put 17 halves first? No. Because 17 halves is what, 8 and a half? And you know, on the number line, you got to go from smallest to largest. So on the number line, in your mind, you really know that this means, this right here means the same thing as what? 1 is
less than or equal to X,
very good, is
less than or equal to 17.
very good. That means the same thing. And so on the number line, you're going to put 1 here, 17 halves here, and open a closed circle. Close them both. Shade in, right? What's the interval notation?
Bracket.
1, 2, 17/8 with a bracket. Okay? That's all that is. That's all you have to do. Let's do another one like this. Let's do 68. So 68. 68.
Wait, can you go back?
What's your question?
Did you mean to write 17/8 with the bracket?
No, I did not. I meant to put 17 what?
2.
17 halves. Sorry. Thank you. 17 halves.
I got a question too.
Yes?
You just, you use, 3 as the least common denominator, and you just multiply it on all sides, right?
Yeah, you multiply all parts by 3.
Yeah, I was gonna say, how does it-
All right, 68. You have negative 1/2 is less than or equal to 3x minus 1 divided by 10 is less than 1/2. All right, don't make it difficult. It's fairly simple to do. You got to find the solution to this compound inequality. There's no way you can guess this thing. There's no way you can guess what the solutions are, so you have to work it out. You have to do the process. So what's the first thing you're going to do to help yourself solve this inequality? Multiply all parts by 10. Very good. So I'm going to rewrite this over. Because the LCD, the smallest number that 2 and 10 go into is what? 10. So I'm going to write it over first. All right, all I did was rewrite this thing over and left some space. So I'm going to say times 10 times 10 times 10, right? What's negative half of 10? Good. So that's equal to, the 10s divide out. That's the whole point. What's left? 3x what? Good. Is less than equal, is less than 5. 2 more steps and you're done. What's the next step? Add 1 to all parts. What's negative 5 and 1? It's less than equal to
3x,
3x. It's less than
6.
6, okay. Last step. Do I need to reverse anything? Nope. So my solutions would be any real number that's between negative 4/3 and what? 2, right? 2. All right, now, on the number line, let's suppose this is 0, negative 1, negative 2, negative 3. 1, 2, 3. Where do I put negative 4/3? Okay, good. You got to remember that negative 4/3 as a mixed number is negative 1 1/3. So that's be between what two integers? Negative 1, negative 2, closer to? Okay, good. Negative 1. So let's say, and it's going to be open or closed? Closed, because the equal sign. So that will be a solution. So this right here would be negative 4/3. All right. And then 2 is easy. That's here. Open or closed? Open. And what do I shade? Everything between them. What's your interval notation? With a parentheses. And that's all this is. That's all you're doing. Now in MyMathLab, there is one with a decimal, so you need your calculator. So for example, number 72. 72. So when you do MyMathLab, make sure you have these problems in front of you. So on the worksheet, I didn't put any with decimals, but on MyMathLab there is one. Okay. All right. So what's the first step?
0.8, subtract 0.8.
All right, good. Subtract 0.8 from all parts. A negative 0.7 and a negative 0.8 is a negative 1.5, correct? Is that correct? Use your calculator if you don't remember that. These combine to get 0, so I'm left with 0.4x. It's less than, now, a positive 0.5 and a negative 0.8 is a negative 0.3. So that's negative 0.3. Okay, what's the next step? All right, now you have to use your calculator with that one because it'll be hard to do in your head. So divide by 0.4. Okay, what's a negative 1.5 divided by 0.4? And with the calculator, you have a calculator. What is it?
Negative 3.75.
Negative 3.75. So that's negative 3.75. It's less equal to x is less than, now what's negative 0.3 divided by 0.4? Negative 0.75?
25. Negative 3.25.
That one? Negative 0.75.
Oh, I put a 1 in front of the 3. my
Okay.
bad.
Now,
Yeah.
can someone verify what she had? Did we hear that?
Yeah.
I have negative 0.5.
Okay. I don't trust you now.
I'm sorry.
So that's negative 0.75. All right. And so on the number line, if this is 0, this is negative 1, negative 2, negative 3, negative 4. So negative 3.75 is close to negative 4, correct? Right here, open or closed? Closed, so remember that's negative 3.75. Negative 0.75 is between 0 and negative 1, closer to negative 1. So that's negative 0.75, and a shaded, oops, did not mean for that to be closed. It's what? Open. All right. And so what's the interval notation? Comma. Parentheses. Okay. So in MyMathLab, there's a one with a decimal, so just use your calculator with that. All right. So in terms of the worksheets, those 8.2s, you can now do those. So let's kind of Part A I've already given to you last week. That's the one with the and statements. Part A was the and statement. Some of you already turned it in. There's like 5 of you that have already turned in Part A. Part B is the or statements. Look at Part B. So those are all or statements. Don't forget the back. Okay? Those are all or statements. All right. Now remember, for each one of those, remember what I want. I want each of the graphs drawn, and then the solution goes here. Okay? So that's part B. Part C is this. Part C are the compound inequalities. And there's the others on the back. Okay, so remember though, here, when you divide both sides by a negative number, you got to reverse the inequality symbols, but you got to have to rewrite it so that I didn't ask you to graph this, did I? All right, I didn't ask you to graph it. All I wanted was the interval notation. Okay, that was a mistake. So I'm going to do another worksheet as well, where I am going to ask you to graph this. But when you do the interval notation, make sure it's in correct order. So don't say from +2 to -3. You're going to say from where? -3 to +2. Okay, so you got to know that. Same thing here. We did something like these. So use your notes to help you with this. And then part D, all part D is a mixture. Part D is a mixture. And, are. Oh, and so here now I'm asking you to graph one. Right here. So there's a compound. Remember, this is really what kind of statement, and or are. This is really what kind of statement, and or are. That's an and statement. No, not an or. We talked about that. It's an and statement. And these are what? This is an or and this is an and. Okay, so it's a mixture of all of those. So part D is a mixture. Now remember, there's no solution. You write the word empty set, and you leave the graph blank. Okay?
Did you want us to graph both of them separate?
Yes, you do. Notice it says this. Show work as what? Presented in class. Our question was, do you want to graph each one separately? The answer is what? Yes. Show work as presented in class. Okay? All right. So you know if you don't, you lose points. Okay, now. Okay. So I'm going to put those worksheets on that side. And then put that here. So that's due, those are due 1 week from, oh, I said, oh, Thursday's Thursday, right? Okay, 1 week from today, so that's Thursday. Then the other two,
8.2 part A.
8.2 part A and 9.3 part C are due when? 9.4 part C. Yep. Look, this is what I told you earlier. This right here. Those that came in late, you didn't see this. Make sure you know this. Okay? All right. Okay, now. Okay, so what we're going to do next class period is this. So Tuesday, yeah, listen up. Tuesday, we're going to start graphing lines. Graphing lines. So we're going to do that. It's not that difficult. We also, though, remember, I still haven't assigned you the worksheet on my math lab, rather, on 9.7. Because those are the ones that had those inequality word problems. So I have to do that Tuesday as well. So the first we're going to do Tuesday is talk about those word problems. Those inequality word problems are very simple. If you can do the 9.4s, you can do this one. And then we'll start talking about chapter 10, which is on graph and lines. All right?
Have one math lab due tomorrow, right?
No, I don't think it's due tomorrow, is it?
No, it's due the 25th.
Okay.
That's good.
All right. Okay. All right, so time for the test.